All right, great job so far. So Adam just passed on, so I am going to call on Kylie. Go ahead and let me know where one of the last four are. Like I was saying before, it's a little tricky because you might not really know some of these. So feel free to pass it on, like Adam just did, or use process elimination. Let me know where some of these go.
Um, let's see. I'm guessing that proteins speed up. Oh wait, yeah, proteins speed up chemical reactions.
Right.
Like enzymes.
Exactly. Yeah. So that was what I was gonna ask next. Like, how do you know that? Oh, sorry. How do you know that they do that? And we talked about it a little bit, and that is going to be what we talk about in our next unit. So next week we're going to get into enzymes a lot more. But yeah, enzymes, that's what this is referring to, what this function is talking about, speeding up chemical reactions. And indeed, enzymes are proteins. So good job. All right, couple more. So go ahead, Kylie, call on somebody else here.
I'm gonna call Dominic.
All right, Dominic. Here, let me move all these to one side here. So if you have any trouble, I could zoom in on there. And let me know where one of these last three go.
Well, obviously it's the last picture, so obviously that would go under nucleic acids. But also, I know it's a nucleic acid because it has the 5-carbohydrate and phosphate group and functional group.
All right, awesome. So yeah, I'm happy you expanded on that. If you just said it was through process of elimination, I would have definitely wanted you to expand on it. But you're right. So we watched a video on nucleic acids, and we've seen this picture in particular a couple of times. Um, and again, it's a little bit confusing, so I'm not terribly surprised it kind of went as the last picture. But from that video we watched nucleic acids, we learned what the phosphate group is and what is made of. We learned about that 5-ring sugar, which Dominic, do you remember what that 5-ring sugar's name is?
Oh shoot, is it Fento?
Yeah, it's pentose sugar, which means it has 5 carbons. But I'll give you a hint. It's the D in DNA, basically.
Uh, Deoxy?
Yep, deoxyribose. Right. So good job. That you're really close there. So deoxyribose is this 5-ring sugar, and as we know now after watching that video, this green square is, what did you say, Dominic?
The functional group. The R
Yeah.
group.
No, that's really more for amino acids. We'd call it more like a nitrogenous base,
Oh yeah.
but functional group would work. It's just not really an R group. That's something you'd see in amino acids, as you can see right up here. All right, good job. So we got two left here. Let me know where these go. A little bit tricky here, and you'll see why in a second. So go ahead, Dominic, put your hand down on me and call on somebody else.
I'm gonna call on a boy Ryan.
All right, Ryan. Do you know where either of these go?
Yeah, let me see. Uh, Cellulose is an example of a carbohydrate.
So you said cholesterol is an example of carbohydrate?
No, I said cellulose.
Okay, awesome. That is true. Cellulose, much like starch, is pretty complex compared to your glucose, right? It's a polysaccharide. It's in fact one of the most, if not the most abundant carbohydrate in the world. It's probably the most abundant molecule in the world, just because it's in all plants and and trees and everything has that cellulose. And obviously, it's not something that we can break down in our stomachs. We don't really have the ability to break it down to get to that glucose that we need. But for example, cows do. They can do it using their forestomachs and break that down and get that. And a lot of herbivores kind of have that a similar setup in their bodies to be able to break that down. All right, awesome. So we got one more. Where could it go? Ryan, pick on one more person. Looks like we got a couple hands still up, but that's all right. we'll give you a chance to participate in either next class or something along those lines.
I'll call on Bianca.
All right, Bianca, do you know where cholesterol goes? You might have seen it. If you remember, we saw a picture of it in the notes. They showed a picture of it, and the video talked about it a little bit that we just watched.
Huh. Let me see if I can remember. I think cholesterol was an example of a lipid.
Yep. Now, how do you know that? Except, like, do you remember the picture that we saw?
Was it in like, it was like one of those phospholipid bilayers, but arranged into like a circle or something?
Kind of. If you remember, it was a bunch of rings kind of put together with a carboxyl group on the end. It had like an OH on the end, which that one's a little bit more confusing because again we got rings, kind of like we have in carbohydrates, but it doesn't have as many oxygen as you'll see in carbohydrates, so that's one thing that'll give it away. And a lot of times when you see pictures, if you know 3 of the 4, you can kind of, by process of elimination, figure out what it is. So looking at the cholesterol, it's a little confusing, but there's not that many oxygen. Like you'd see in carbohydrates. There's no nitrogen like you'd see in protein or nucleic acids, which really leaves it to just be one thing, which is the lipids. So, not the easiest way, but cholesterol along with, steroids and some of your hormones, those are lipids, and they look a little bit different than these fatty acids or glycerol. But good job. I'm happy you didn't fall into the trick here of putting it into the protein, which didn't have an example. But can anybody tell me an example of protein that might have gone here? Go ahead, Tim. Tim's raising his hand for you people at home.
Enzymes are protein.
Yep, enzymes. We talked about the functions right here, speed up chemical reactions. That would definitely go in examples there. Anything else? Think about food, right? What kind of foods have proteins? Madison, go ahead.
Like chickens or meat?
Yeah, meat is exactly what I was thinking. Chickens, and even more on the subject of chickens, eggs. All of those would definitely work as examples of proteins. But I don't know why. I don't know if they put that in here when they first made it to kind of like lead you to put stuff in there from the process of elimination, or they didn't want to put enzymes and speeds up chemical reactions in there because they kind of go hand in hand. But awesome, great job. So hopefully you were following along with us as we filled this out, and you should have a table that looks like this. And this kind of turns into a handy little graphic organizer of the things that I really want you to learn about the different biomolecules. Obviously what the monomers are, the pictures, functions, and different examples are all going to be pretty important when discerning between the different macromolecules. Obviously, there's other things like how they're bonded together. What they're called as they kind of grow. Obviously, like monosaccharide versus polysaccharide, etc. And those things are in the notes too. But I think this is a very handy way of kind of knowing the key information. All right, awesome. So we're just about out of time for class. So what I want to do is I want to just show you what I'm going to assign you for homework, and you could use that graphic organizer to work on that. So I have it published as Macromolecules Review Sheet. So over the course of this weekend, open this up, and it'll it'll be a worksheet form kind of that table that we just did. Oops. Sorry, technical difficulties. Let me open up the right module here. Excellent. So click on this, and you will see that um, we have these questions, which again kind of talk about what you'll find in the notes. We see a lot of the same nomenclature that we saw on that table. So go ahead and fill that out for homework, and I'll be able to kind of get a gauge on how much you took away from this and what you took away from the notes. Like I said, after this, we're going to be starting on enzymes. So it's good to know it's good to know about these macromolecules before we move on to more specific functions of those macromolecules. Okay, so does anybody have any questions about that card sorting table we just did, or this assignment here? All right, awesome. Well, that's all for me today. So you guys go ahead, have a great rest of the day, have a great weekend, and come Monday, look forward to learning about some enzymes. All right, have a great one. Bye.